Okay, again, nonlinear optimization. And so here, so nonlinear optimization actually doesn't have to look like linear. Okay, so it may not lend itself to be written down that way. And actually, a problem that we already mentioned, scheduling control flights. For beetles. The beetles weren't doing the flights, of course, but although they can fly. So that, and I don't think I mentioned it in the other, that was actually my master's thesis. But in this case, the model didn't really lend itself to looking similar to a linear model, but just with nonlinear terms. And so in this case, I had to use a different technique. And I've used this technique on a couple of problems. The basic idea in this different technique is you sort of finish, you say, you know, this is maybe where I finish, and you start looking backwards at all the possibilities. And this gets a bit unruly, you know, because this was, you know, say possibility 1, possibility 2, possibility 3. But then, you know, these have different possibilities, and it could be they branch or something like that. And so it can really get out of hand if you have a very big problem. But at any rate, to actually look at that control flight, you know, what I did was I said, well, you know, we want to have a last flight at some point in time, and you know that point in time could be here, 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 and I said, well, if that's when the last flight happens, where should I, you know, say I'm doing 3 flights, so that was flight number 3. Where should I have done flight number 2 and flight number 1? And you sort of work backwards to get that optimization. We won't, I don't think we're going to look at this technique in class, but it doesn't mean you couldn't use this technique in your semester project if you decided to, you know, on a problem that just lent itself to this particular type of technique.